All right, for page 74, we're still solving radical equations, except this time the one that we're going to paste in is the one that says to solve a radical equation containing two radicals only. So we're going to isolate each radical on opposite sides of each other. We're going to raise both sides to the least common multiple of the bottom of the exponents. We're going to expand the expressions if we have to, get 0 equal on one side, and then we're going to solve and check our answers. So, looking at this first example, you'll notice we have two radical equations. They don't look like radicals immediately because of those fractional exponents. But remember, fractional exponents, the denominator turns into a radical. So this would both have a cube root of x plus 1 squared minus the cube root of 9x plus 1 to the 1 power. So we do have two radical equations even though it doesn't look like it. So we're going to move them to opposite sides. That's what it said to do first. So when we do that, it looks like this. Step 2 said to use the LCM on both sides to raise each side to that LCM, the least common multiple. So 2/3 and 1/3, we're only looking at the denominator. It said to look at only the denominator. The LCM is 3. So what that means is I'm going to raise both sides to the third power. So that's what it have on this step. Now we have x plus 1 to the third, 2/3 to the third. Remember, we multiply these two exponents here, which leaves me with x plus 1 squared. And then on the right-hand side, we have 1/3 times 3, which is going to be 9x plus 1. The next step was to FOIL if necessary, or expand, which I do here. So I'm going to get all of this expanded. When I do that, it becomes x squared plus 2x plus 1 equal to 9x plus 1. The next step is to get everything on one side and the other side equal to 0. So I'll subtract 9x and I'll subtract 1. So I get x squared minus 7x equals 0. You'll GCF a x in order to be able to solve this. You'll get x parentheses x minus 7 equal to 0. And your two answers are going to be x equals 0 and x equals 7. So we'll plug in 0, for example, to see if it works. When you plug in 0, you get 1 to the 2/3. That's just 1. When you plug in 0, you'll get 1 to the 1/3, which is just 1, and 1 minus 1 is 0. You could plug in x equals 7 and do the exact same thing. And when you do that, you will end up with 0 as well. Okay? For the next example, example 2, we have 2x plus 1 to the 1/2 minus x plus 11 to the 1/4 equals 0. Please remember this 2 at the bottom means that this is going to be a square root symbol, and this is going to be a fourth root symbol. Okay, so these are two radicals even though they don't look like it with these fractional exponents. We're going to move this one to the opposite side so that it looks like this now. Looking at just the denominators, I have a 2 and a 4. The least common multiple between the two of those is the number 4. So I'll raise each side to the 4th power. When I do that, I get 2x plus 1/2 to the 4th, x plus 11 to the 1/4, all to the 4th power. And then from here, we're going to multiply these two exponents to get 2x plus 1 squared. And then these two right here are going to become the number 1. We'll expand the left-hand side, and it turns into 4x squared plus 4x plus 1, and then the right-hand side just becomes x plus 11. We'll put everything on the same side together, so we'll subtract x to get 3x, we'll subtract 11 to get 10, and now this turns into a quadratic equation, which allows you to be able to factor. So whether you use the a times c method or the cross method, you'll factor at this point. You'll get 4x minus 5 times x plus 2. You'll set each of these equal to 0. You'll get 5/4 and x equals -2. And so when I went back and plugged in the -2 into the original, it says that it made my radical negative. So for example, right here, when we do -2 times 2, that's -4, plus 1 is -3. So this would expect me to take the square root of -3, which is not possible. So I know that I have to get rid of that answer. So if you want to check 5/4, you can go ahead and plug that in, make sure that it works, and that you truly do get 0. You may have to use your calculator in order to make it happen, I'm not sure, but you can do that if you need to. Okay, and that is it for this page.